Okay, today we're going to discuss about the eigenvalues and eigenvectors. We have skipped the topic about the linear transformation. However, in this topic, we are going to incorporate it as we deal in solving the eigenvalues and eigenvectors of the given linear transformation. Now, as you have recalled, and as we have also touched now about linear transformation and in your other subject as well, um, I think you have encountered this. Now, we can compare linear transformation from the rigid motion, in which when we talk about rigid motion, there is translation, there could be rotation, no? Or reflection of a given pre-image, no? Or and the output is what we call the image. Now, in linear transformation, we could have in linear transformation also those mentioned the rotating, the translating, no, of the given line or linear equation. But aside from it, we could also have the scaling, meaning we could also stretch the values or the coordinates, no, or shrink, no, depending on the transformation, as long as it preserve its geometric structure. Now, as we deal here now, we have example. Let L, a linear transformation from P1 to P1 be the linear operator defined by L of AT plus B equals BT plus A. So what does it mean here? It means that from this given, let's say this is the pre-image, the linear transformation of this expression will be this. It will be now bt plus a. So as you notice, the change that happened is that a and b um, coefficients have interchange. That means if let's say we have AB from our image, no, from our original linear, it will transform into BA. Because as you notice in the transformation, there is interchanging of the coefficients A and B. Now, using this matrix representing L with respect to the basis 1t. So, this will be our basis now for our P1. So, this P1, again, has a linear transformation defined by this operator. There will be interchanging of A and B values later. Now, find the eigenvalues and as well as the associated eigenvectors for the given eigenvalues of L. Now, from the given, um, we will define each of this now based on our basis. Now, let's start with our T. Okay, because our bases are 1T, so we will start first with our T. Um, if T will remain, I mean, we will start with 1. Okay, we will start here with 1. Okay, 1. 1 should be the result, no? Because this is the basis. 1t is the basis for the image of the transformation or linear transformation. Now, for 1 uh, will result to, okay, wait lang. For 1 to be the result of the linear transformation, what will be or what should be the values of B and A? Okay, for 1 to be the result. Okay, given this linear transformation. Okay, and given the basis now that, okay, we said we will begin with 1. So what should be the value of A and what should be the value of B from this so that it will result to 1. Okay, now as we deal here, of course, B here should be 0. Okay, so that 0 times t is 0. Wala sang t nga mag-equal dire. Okay? And A should be 1 so that this bt plus 1, this operator defined by bt plus 1, will equal to 1. Okay? As our basis. Din nga 1 gani para sa aton basis nga 1. So we have defined here, no, that B is 0 and A is 1. So that is now how we will form later our matrix for getting the eigenvalues and the eigenvectors. So we have 0, t. Okay, so you have to take note of that. Okay, we have 0, 0, 1, 0, 1. Okay, so that is from the linear transformation for the basis of 1. Now, the second is that ang t naman, how will we derive a t result from this operator bt plus a? What should be the value of a and what should be the value of b? So, since this is a, kaya gusto natin t lang bilhin, syempre, ang t, ang coefficient of t, which is our b, should be 1. And here, it should be 0. A should be 0. So that 0 times 1 is 0. And it will be equal, or it will be equal to 1. Or it will equal to 1. It will be equal to t. Thus, noting our coefficient is 1, 0. Okay, 1, 0. Thus, forming our matrix, this will now our matrix 0, 1, 1, 0. Okay, ano siya? Okay, this we have 0, 1, 1, 0 for our matrix. So this, again, our matrix A. Now, we will get, class, the determinant of this matrix A. But first is, we have to write. Okay, now we will subtract the eigenvalue. Now, this eigenvalue, class, okay, it's represented by this symbol, lambda. Now, this is a symbol for a Greek symbol called lambda that will represent our eigenvalues. Okay, this will represent our eigenvalues. Now, from our matrix 0, 1, 1, 0, we have two options to do, to get the characteristic equation. First is, we can directly subtract this eigenvalue or the lambda. Okay, we can say, let's say, from 0, 1, 1, 0, you can subtract directly lambda from the diagonals, only from the diagonals, Okay, 0 minus lambda. Okay, so again, we may subtract directly the lambda, okay, from the diagonal and then solve for the determinant. Now, there is another option. Okay, kay kung dire, if you try to solve the determinant, there will be cases nga it's hard to deal if your negative is on the variable. So you have an other option in which you may okay, it's not always the case that zero, the diagonal are all zero. It's not always the case. So there will be times that there are value, no, there are times that your diagonal are non-zero. That is why if non-zero, let's say 1, 2, 3, 4. So if you subtract minus y or minus the lambda, okay, what, and you cross multiply, or you, when you get the determinant, you need to multiply 1 minus lambda and 4 minus lambda. Now if this is the case, no, sometimes it will be hard, or there will be a misinterpretation later on when you factor out, because the negative, you know, or the negative is in your variable. Now, as much as possible, we want that our variable is positive. Okay, so we want, no, some most of the time that our variable is on the first um part of the equation. We would rather to see y minus 1 and or lambda minus 1 and lambda minus 4 rather than this. Okay, so the second option that you may have is that you um, change the sign of all the values or entries in your given matrix. So that is what happened here, where 1 becomes negative and another here 1 becomes negative. Now, instead of subtracting to the values of the what you call this, aside instead of subtracting the lambda from the values of the diagonal, you will just have the lambda subtracted by the values from your diagonal. So that is now lambda minus 0 and then lambda minus 0. So you have two options again, or 0 minus lambda, but positive, retain the sign, positive also, dire, and then lambda minus, 0 minus lambda. So, either of this, when you get the determinant, you will still derive on the same characteristic, no, of our equation. Now, solving the determinant, okay, oh, simply here, no, multiply y minus 0 is y minus 0 again is y, cross multiply y, lambda times lambda. Sometimes I called it y because it looks like a y. And if I say, or I call it lambda, it will be too long to read. That's why sometimes I call it y. You can also call it x if you want. But again, this is lambda. Lambda times lambda is lambda squared. And then minus the product, no, of the other 2 and 3. Negative 1 times negative 1, that is positive 1. So again, minus positive 1 equals 0. Again, we simply equate them to 0 to get the characteristic equation. You equate the determinant to 0. Now, after this, now this is the characteristic equation, then you will solve the lambda values or your eigenvalues. Again, this is the eigenvalue. It's just a variable representing the eigenvalue. Now, apply the factoring now of polynomials. We have lambda minus 1 times lambda plus 1. Solve each of the factors by equating to 0, and we get lambda equals 1 and lambda equals negative 1. Again, this is the eigenvalues. Now, after that, we are now going to solve for the eigenvectors from these eigenvalues. Now, we will start with 4 lambda equals 1. Now, what we will do is that we simply substitute this lambda value or the eigenvalue, no, to this matrix. Okay? Again, we will simply subtract it from this matrix. So we have now 1, negative 1, negative 1, 1. And then what we will do next is that we will solve or we will solve it or do the row matrix operation and transform it into REF, row, reduce row echelon form, EF. Okay, reduce row echelon form. As we transform it into reduce row echelon form, this is the result. Okay, the last row are all 0 and 3. Thus, our value, no, okay, we have to solve for x sub 1, x sub 2. It's like we have to form the augmented matrix, but we are not writing anymore here the augmented matrix because it's still 0, 0. Okay, but if you really want to know, just to show you, okay, let's consider 1, negative 1, negative 1, 1. Okay, we have 0, 0. Now, adding this, we will get what? Adding R1 plus R2, result to R2, we have 0, 0, and then 0. Now, again, this is x sub 1, this is x sub 2, because we need to solve for x sub 1 and x sub 2. But x sub 2, in this case, is has infinite many solution. Meaning to say, x sub 2 can be any value. Thus, we simply equate it to a variable. Here, we choose s. Okay, we choose s. And then, if x sub 2 is s, as we deal here, on our first row, we know that x sub 1 minus, since it's negative 1, minus x sub 2 equals 0. Since we know that x sub 2 is s, we replace it here from our first equation above here. We will now have x sub 1 minus s equals 0. Thus, our x sub 1 is equal to positive s. Forming the vector, we have, okay, diba, x sub 1, x sub 2. Thus, we have s, s. Now, what we will do is we will factor out, okay, we will factor out s from this. So, what will left from our vector are 1, 1. Okay? So, this is now the vector, now the what we call the eigenvector. Okay, hindi ang s but just ang 1, 1. That is our eigenvector for lambda or eigenvalue equals 1. Okay? Sorry siya. This is our first eigenvector. Now, next is we're going to solve for the eigenvector for the eigenvalue equals -1. The same process, substitute, and then solve for, transform into RREF, reduced row echelon form, and solve, no. Now, in this case, you also use the variable s, no, x sub 2, the last column, okay, this is the RREF form. Our last column, x sub 2, is equal to s because since 0, 0, ang aton, all 0, ang aton row, then it means that we can have any value, no, to for our x sub 2 because we have infinite many solutions. So we let it equal to s. The same pattern if x sub 1, for x sub 1, when we write it into an expression, that will be x sub 1, or equation, x sub 1 plus x sub 2 equals 0, replacing our x sub 2 by s, okay, plus s, this is x sub 1, plus s equals 0. So we have x sub 1 equals negative s. So our x sub 1 natin is equal to negative s. So from this, okay, we have negative s. So, and pagwaon ng si s, we have negative 1, 1. Therefore, our second eigenvector is negative 1, 1. Therefore, the associated eigenvectors of linear L is, or are, 1, 1 and negative 1, 1. Now, there is also another example in which, no, it's P2 na makagina, it's P1, meaning we only have a linear transformation, no, a transformation from given linear equation. Here, we will have P2 that is second degree polynomial. Kagina, it's first degree polynomial. So, ang iyang transformation naman is defined as t squared plus bt plus c is transformed, no, to ct plus b. So, ang array, do medyo malaba, no, ang iyang sorry, process. Okay, medyo malaba ang iyang process. Now, in the test, there will be sometimes a case lang, I want you to show lang ang iyang characteristic equation. And I'll just send also, no, di ko na pag-discuss gid ni patamaan, kay medyo malaba gid man ni ang iyang process because we will have 3 eigenvalues and 3 eigenvectors. Now, I just want to discuss how you are going to form the characteristic equation from this given linear transformation. But in the test, what might come up is might be 2 by 2 lang para mas hapos nyo siya ma-solve. Kaya diri, we will have 3. So, sometimes it's hard to factor out, no, or to do factoring for cubic, no, nga equation. Now, so let's have this. We have at squared plus bt plus c forming, no, the basis t squared, 2 plus t, this is 2 plus t, 2 plus t, and then 2 minus t. Okay, that is 2 minus t. Now, as defined in our linear transformation of P2, ang A na wala na si A, no, sa iya nga pag-transform. So, ang iya nagwa, do ano siya, no, from this, nagimo na lang amon eh. That's meaning to say, ang iya nga A is 0. Klaro? Okay. Now, so this is how we're going to deal with this. From our first transformation, we have t squared. Okay, diba t squared ang first natin nga basis. So, imuon natin ni siya t squared. If this will be t squared, what will be the value of a, b, and c? It's obvious, para t squared siya, ang imo nga, diri, no, ang imo nga mga values for this should be 0. Ang imo b and c should be 0, and a should be 1 para t squared. Now, kay hambal naton, amo ni ang aton nga values of a, b, and c, coefficients. Therefore, ma-transform siya, no, to this transformation defined as ct plus b. That means, pero kompleto man na Japon. Okay, may ara ikaw Japon, t squared, may ara Japon ikaw sang t, may ara Japon ikaw sang constant dire. But however, nagsaylo. Si A mo wala na si A, pero ara man Japon siya sa t squared. Okay? Kay karon we need that, no, to form the matrix. Si C mo diri na sa may T. Okay? And si B mo diri na siya. Okay? But we need later on here, may ara man kita Japon na dira ang 1. Okay. Now, as defined here, only CT plus B ang nabilin. Therefore, as we transform it, 0 CB and 0 CC. So, 0 CC here, and 0 man si B. Klaro kita dire? 0 si B and 0 si C. Okay, they are all 0. We will have the transformation. May ara kita 0. Dali lang. 2 minus t and 2 minus 1. Okay. Again, ang basis na to, no? We have t squared, 2 minus t, and 2 minus 1. Okay, ari si 2 minus 1. This is gamay ang agi. 2 plus t. This is 2 minus t. Zoom in ko lang. 2 minus t. 2 minus t. Okay. Okay, kay di ba all 0 sila ni dire? Therefore, our equation or our first dire nga ma-form is 0, 0, 0. The first vector that we formed is 0, 0. Now, the same, what will happen here sa aton nga 2 plus t naman. Okay? For 2 plus t, para mag 2 plus t dire, no, sa transformation naton from here, from the given, gali, of course, a should be 0, kay 2 lang, okay? And t, our b should be 1, para mag t na lang. And then for c, dapat si c mo is 2. Kaya ang constant natin is 2. So, amo ning aton dere ha. Now, if a is 0, b is 1, and c is 2, from the transformation, ct, so c, 2t, we have 2t, plus b, which is 1. Now, forming from the bases, again, we have to go back sa aton nga bases. Okay, now in this case, you need to think of, okay, diba, we have the bases t squared, 2 plus t, and 2 minus t. You have to think of a constant or a coefficient value of here, no, that when you multiply or when you solve, it will go back to 2t plus 1. So, hindi ko na lang magpalawikon, just to show you na lang. Anyway, in the test, I will just give you a 2 by 2. no? Para mas madasig nyo lang siya, mas solve. No area, we have 5, 4, and tapos 3, 4, minus 3 over 4, and then amo na siya. Distribute lang, mabalik na siya sa 2t plus 1 and so on. Now, the same goes, no, on our second base vector, that is 2 minus t. So, you have to get values of a and b, kung ano na ang para mag-go siya sa 2 minus t. And then, balik naman kita sa definition or sa linear transformation definition. Okay? That's just defined by 2t minus 1. Ano kay na ct, gani ct plus 1. So, what should be? We have b equals negative 1. So, RCB, ang cc natin is 2. Therefore, we have this. Now, you have to think of the value of the coefficients, no, that will result to 2t minus 1 for the respective bases. Okay, and that's it. Now, mag-form sang vector. Now, from the vectors, ibutang mo siya as the matrix representation. Okay, change the sign. Then, write lambda minus for the tawag niya, diagonal. Okay, solve for the determinant, and then you get the characteristic equation. Okay, so medyo malaba na ang pag-solve niya. So, after you get the characteristic equation, solve for the value of the eigenvector. Then, the same process kagina, solve for each eigenvector for the corresponding eigenvalues and so on. So, ano ko lang ni i-leave ko lang ni, no, as study guide lang sa inyo. However, again, ang fokusan nilang igawa is for the 2 by 2 lang. Okay, for the P1 or polynomial of degree 1. Okay, that's it for now.